Today we're going to be looking at the queue data structure. You may have heard us talk about stacks and how they're last in, first out, often referred to with the acronym LIFO. Queues are similar to stacks but with a few differences. The main difference is that whereas stacks are last in, first out, queues are first in, first out, which is usually shortened to FIFO. This simply means that the first item that goes into the queue is the first item that's served. You can think of it much like any queue you'd see or be in, whether it's standing in line at a supermarket or queuing up on the stairs to get into an aeroplane. So now that we've understood what a queue is, let's start making one. First off, we're going to add a generic type to our queue class to allow us to specify the type of data our queue will store. The first method we want to implement is going to add an item to the back of the queue. This is going to be a public method that doesn't return anything. It's called onQueue and takes in an item. The next method is going to be one to remove an item from the front of the queue. It's going to be another public method. This time it's going to return the value of that front item, which is going to be typed as t, and is going to be called dqueue. Now let's declare a private class called node that's also going to declare a generic type. This class is private because we don't want anything outside of the queue class to directly access it. We have the onQueue and dqueue methods we put just below for that. So this class is going to have two fields. One called data that will store the value of the item in the queue, and another called next, which is going to be a reference to the next item in the queue. The last thing for this class is the constructor, and all that's going to do is assign the value of the item that gets passed in to the data variable we created at the top. Now let's declare two fields at the top typed as instances of the node class we just made. These are going to be called front and back and will be references to which item is at the front of the queue and which one is at the back of the queue. Now, we have what we need to start implementing the onQueue and dqueue methods we declared earlier. So for our onQueue method, the first thing we're going to do is check if the front of the queue is empty. If it is, then we'll make a new node with the item we want to add and place it on the back of the queue. Since it's our first item though, it's also at the front of the queue. But if there is an item at the front of the queue, then we're going to make a new node for our item and link it to the node that's at the back of the queue. Then, when we add our new item, the second last node will be pointing to the one we've just added. So for the dqueue method, let's start by making an item that doesn't have a value and just set it to null. This is going to be the item we return at the end. Next, let's check that there is something at the front of the queue. If there is, then we can assign data of the front node to item, and the second node in the queue becomes the new front of the queue. Lastly, we will return the item. Now that we have our queue class, let's use it somewhere. So let's head to our main class where we're going to type our queue, tell it that all of the items for it are integers, and instantiate it. In addition, let's add some items onto our queue. So we're going to use our onQueue method to add an integer, and let's add a couple more. After that, we'll have a look at our queue. So let's print out some descriptive text, system.out.print my queue with 3 items, and then the contents of our queue. System.out.println my queue. On top of that, let's also use our dqueue method to take one off and take a look at it. So let's call our dqueue method and assign the result. Next, we're going to print out some more descriptive text with system.out.print dqueued item. Then, we'll also print our removed item using system.out.println the variable dqueued item. Lastly, let's just have a look at what's left on the queue after we remove that front item by doing system.out.print my queue with one item dqueued and system.out.println my queue. Now in our stacks video we tried to print out the data structure like this and saw that it just printed an object reference, so we needed to override the toString method. We'll need to do the same thing here. Let's import ArrayList, which we're going to be using for this. We'll need to add the override annotation and our new public method that's going to return a string called toString. In it, we're going to make a new variable called current that's going to point to the front of our queue. Then, we're going to declare a new ArrayList that's just empty. After that, we're going to write while current is not equal to null, we will add the data of that node to the queue items ArrayList and then set current to point to the next node in the queue. So what's going to happen is, we're going to iterate through every item in the queue and add its value to this array. And when it gets to the end, Because the very last node won't have a value for next since there's nothing after it, it'll break out of the while loop. Lastly, we're going to call the toString method on our array list, which has all of our items, and we're going to return that. Now, let's head back to the main class and run our code. In the last video, we were running our code in IntelliJ. This time, we're in VS Code, so we have to manually compile our queue and main Java files by passing our class files to the javac command, and then we can run it with Java main. You can see our queue with the 10, 20, and 30 integer values in it. After that, we dequeue our first item, which we can see here with the value 10 printed out. Below, we can also see that our queue doesn't have 10 anymore. That's it from us today, everyone. Let us know what you thought in the comments down below. If you liked the video, don't forget to give us a thumbs up and subscribe.